On February 20, 1943, in the lifeless wastelands north of the Kasserine Pass in Tunisia, German tank commanders unwittingly witnessed a frightening phenomenon that would forever change their understanding of modern warfare. American Sherman medium tanks, operating in clouds of dust and smoke, performed the most complex tactical realignments which, according to all the charters and doctrines of the Wehrmacht, were absolutely impossible without direct visibility or the use of signal flags. Through the haze of African heat, 5 American combat vehicles, separated by difficult terrain and devoid of visual contact with each other, converged on the German positions with frightening, almost supernatural synchronicity, as if they were controlled by one invisible hand. There were no flares slicing through the sky, no motorcycle messengers desperately maneuvering between the craters, no commanders leaning out of the hatches to make hand signals. Nevertheless, this group moved like a single predatory organism, where each tank instinctively covered its comrades' blind spots, and each crew had absolute knowledge of the location of its allies. At the same time, chaos and despair reigned inside the cramped turrets of the German Panzer IV tanks, equipped with standard Fug 5 radios, as the commanders tried in vain to hear the orders of their company officers through the deafening crackle of static which completely suppressed their outdated amplitude modulation systems. German 10-watt transmitters, which in the 30s were considered the pinnacle of engineering and the state standard, now demonstrated their complete failure by not penetrating the airwaves for more than a few hundred meters during the movement of the column.
Most of the German tanks in these platoons carried only receivers on board, which made their crews mute witnesses to their own deaths, unable to report what they saw, request artillery support, or warn their neighbors about a flanking bypass. The Americans, on the other hand, operated with technology, the existence and effectiveness of which the German command did not even suspect, believing it to be science fiction. In absolutely every American tank, from the commander's car to the battle tank, there was a frequency-modulated radio station that provided crystal-clear communication thanks to quartz stabilization and 25 watts of transmission power, which allowed the commander's voice to cut through the noise of engines and the roar of battle like a red-hot knife passing through oil. 8,000 miles away from the assembly lines of Detroit, in the sands of North Africa, the most decisive and underestimated technological advantage of the Second World War was revealed, which was not at all in the thickness of the frontal armor or the caliber of the main gun, but in the invisible electromagnetic waves connecting every American crew into a single information network. This invisible revolution began long before the Allied landings, namely on July 22, 1941, when the United States Army Signal Corps decided to standardize the radio sets of the SS R Series 508, 528, and 538 for installation on all medium tanks. While Guderian and Goth's tank wedges cut through the defenses of the Soviet Union, relying on blitzkrieg tactics that critically depended on radio communications, but provided them only to command vehicles, American engineers in the laboratories of Galvan manufacturing, which later became known to the world as Motorola, made a real technical breakthrough. The engineering team, which included visionaries such as Daniel Noble, who pioneered the concept of using frequency modulation in military technology, and Henryk Magnuski, chief radio frequency engineer, solved the incredibly difficult tasks of installing fragile and complex electronics in the harsh conditions of a vibrating, overheating, and dusty tank. Their creation, weighing an impressive 181 pounds, actually turned every serial Sherman tank into a full-fledged node of the first real-time combat network in the history of mankind. The BC-64 transmitter generated an output power of 25 watts, which was 2.5 times more than the German equivalent of the Fug 5, and this power advantage played a huge role in rough terrain. Operation in the range from 20 to 27 and 9/10 megahertz provided 10 preset channels with quartz stabilization, which eliminated the need for constant frequency tuning in the midst of combat, a problem that German radio operators suffered from.
The dual BBC 603 receivers included in the SS R508 set
gave commanders a unique opportunity to simultaneously listen to two different frequencies, for example, the channel of their platoon and the channel of the company command, which provided a continuous stream of tactical information and allowed them to instantly respond to changes in the situation. However, the real revolution lay not so much in hardware as in the very principle of frequency modulation developed by the brilliant Edwin Armstrong. This technology, licensed by the military, almost completely eliminated static interference and interference, which were the scourge of amplitude modulation systems used by the Axis countries. While German tank radios picked up every electric discharge, every spark from the ignition system or generator as a deafening crackle, American FM radio stations transmitted a clear human voice even during massive artillery bombardments, when the airwaves were literally boiling with electromagnetic disturbances. On November 8, 1942, when Operation Torch began and American armored vehicles landed on the coast of North Africa for the first time, tanks of the 2nd Armored Division came ashore near Safi and Fadala, carrying on board the very radios that were soon to prove their absolute superiority over the German communication system. The German Africa Corps, despite its status as an elite unit and the vast combat experience gained in battles with the British, operated under conditions of severe information starvation and communication restrictions. A standard German tank platoon of 5 vehicles usually included only 1 or 2 tanks with full-fledged transceivers capable of both transmitting and receiving messages, while the rest of the vehicles were essentially deaf, having only receivers for receiving orders unilaterally. This created a rigid hierarchical structure where the initiative of subordinates was suppressed by technical limitations. The platoon commander gave orders, and subordinates confirmed them not with words, but with actions, turning the turret or moving the tracks. This vulnerability became fatal at the moment when the commander's tank, which was easily identified by the enemy by its characteristic frame antenna or multiple pin antennas, was hit or destroyed. In the same second, the entire German platoon turned into a herd without a shepherd, lost coordination and the ability to organize resistance, while in the American units, each tank, thanks to a full-fledged radio station, could immediately take command and continue the combat mission. The Battle of Kasserine Pass, which lasted from the 14th to the 24th of February 1943, became the first major training ground where American radio communications were tested by combat and demonstrated their capabilities to an astonished enemy. Although tactically this battle ended with the victory of experienced German troops, it revealed such command and control capabilities for novice Americans that baffled Wehrmacht analysts. During the chaotic battles when the front line was constantly changing, the disparate elements of the 1st Armored Division of the United States managed to maintain coordination and control on the 50-mile front. The tank crews, who had never met before and belonged to different units, instantly interacted, coordinated counterattacks, warned each other about anti-tank artillery ambushes, and called out howitzer fire with such speed and precision as if they had been training together for years. The radio interception services of the 10th Panzer Division of the Wehrmacht noted with alarm the exceptional clarity of the American negotiations and, more importantly, the fact that communication was maintained at such distances where German analog devices produced only useless noise. Even more alarming for the German command was the realization that every American tank, without exception, was apparently capable of full-fledged two-way communication, not just specialized command vehicles. The German Fug 5 radio stations, which operated on the principle of amplitude modulation in the range from 27 to 33 3/10 MHz, suffered from fundamental physical limitations that could not be overcome by simple modernization. Their 10-watt transmitters could hardly finish off 2 or 3 kilometers in ideal range conditions, but in the reality of combat, when the tanks were moving over rough terrain, the communication range dropped to a measly hundreds of meters. Every spark in the spark plugs, the operation of every electric motor turning the tower, every movement of the metal tracks created powerful electromagnetic interference that the AM systems could not filter out, turning the ether into a solid wall of crackling. September 1, 1943 marked the arrival of American armored vehicles in the Italian theater of operations, where the most difficult mountainous terrain, it would seem, should have offset any advantages of radio communication due to the shielding of the signal by rocks. However, in practice, FM technology proved its even greater value precisely in these adverse conditions, finally making German AM radio stations useless cargo. The frequency modulation of the SSR 508 radio stations coped with the phenomenon of multipath propagation of radio waves in mountain valleys much more efficiently than amplitude modulation, allowing the signal to bypass obstacles and be reflected without critical loss of quality. The American tanks coordinated their maneuvers in conditions where visual signals were impossible due to terrain folds, and German communications were completely out of order. During the offensive on the Gustav Line and the battles of Monte Cassino, American armored units demonstrated such possibilities of interaction that contradicted the entire German experience of waging war in the mountains. Tank platoons, separated by high mountain ranges and located in different valleys, coordinated their attacks in time with 1-second accuracy, which German doctrine required to achieve only with direct visibility. The reports of the 1st Armored Division after the fighting described cases of routine coordination of actions at distances where German radio stations could not provide even the simplest signal reception. On June 6, 1944, on D-Day, when the first Shermans rolled off the ramps of amphibious assault ships onto the beaches of Normandy, their SSR 508 radio stations were already in steady contact with fire support ships correcting naval artillery fire on German bunkers, a level of interaction absolutely unattainable for the German technicians. However, the fighting that followed the landing in the bocage, the dense hedgerows of Normandy, revealed a critical gap in the communications system that could have cost the lives of many crews. It turned out that the tank radios could not communicate directly with the infantry walkie-talkies, as they operated in a completely different frequency range. The SSR 300 infantry radio station operated at frequencies from 40 to 48 MHz, which was completely incompatible with the tank range from 20 to 27 9/10 MHz. This communication gap turned out to be deadly in conditions of limited visibility among hedges, where German infantrymen armed with Faust cartridges could get close to American tanks, while American infantry walking nearby did not have the technical ability to quickly warn tankers of the threat. However, American engineering ingenuity and flexibility of thinking made it possible to solve this problem in just a few weeks right in the field. Tank crews began to mount conventional E8 field telephones into empty ammunition boxes, welding them to the rear of the tanks and connecting them with wires directly to the tank's internal communication system, creating a simple but effective infantry-tank interface. By the beginning of Operation Cobra at the end of July 1944, this seemingly artisanal modification had become the standard and revolutionized the tactics of interaction between the armed forces. An infantryman could simply run up to the tank, pick up the phone, and point the crew commander at a machine gun nest or a hidden Panther. The period from the 25th to the 30th of July 1944, when Operation Cobra was unfolding, demonstrated to the world the full potential of American radio superiority and the concept of network-centric warfare, although such a term did not exist then. The 2nd Armored Division, under the command of Major General Edward Brooks, coordinated the actions of more than 200 Sherman tanks through complex, multi-level radio networks that provided an unprecedented level of control over the battlefield. The German defenders from the elite Panzer Layer Training Tank Division faced an opponent who seemed to have the gift of foresight and omnipresence.
American tanks reacted to threats instantly, even if information about them came from units located several miles away. Artillery strikes coordinated through tank radio networks rained down on German positions literally a few minutes after their detection, without giving the enemy time to change positions. The contrast with the German capabilities during this period was simply striking and tragic for the Wehrmacht. The Panzer Layer Division, once the pride of the German tank forces and a model of equipment, was reduced to a state of communication poverty. Most of its tanks operated without radio communications, relying on primitive visual signals in an area where visibility rarely exceeded 100 meters due to dense vegetation.
The few radio stations that were still functioning suffered from constant interference and a limited range, making effective counterattack coordination impossible. The deepest irony of the situation was that it was Germany that pioneered the use of radio in tank forces. The legendary Heinz Guggenheim, the father of tank forces and the architect of the Blitzkrieg strategy, insisted back in the 20s of the last century that every tank should be equipped with a radio station. In his book Achtung Panzer, published in 1937, he emphasized that communication is the circulatory system of tank operations. Guderian developed radio communication systems that allowed German officers to brilliantly coordinate attacks at the beginning of the war. He was well aware that the rapid breakthroughs of tank wedges required reliable and instant communication. However, by 1943, German industry, overloaded with orders and suffering from a shortage of resources, simply could not produce radio stations in the volumes required by Guderian's own doctrine. German production statistics clearly demonstrate the depth of this crisis. In 1943, Germany produced about 5,700 medium tanks, but produced less than 2,000 full-fledged Puffer series transceivers. A huge number of these precious radios were used to equip command vehicles and assault guns, leaving linear tank companies in a state of acute shortage of communications equipment. The Soviet tank forces, by the way, experienced an even more terrible communication hunger, where even the legendary T-34, the most massive tank of the Allies, as a rule went into battle without any radio equipment at all. Soviet doctrine had to rely on flag signals and detailed planning before the battle, which led to catastrophic losses in a collision with the maneuverable enemy in the 41st year. By the 43rd year, lend-lease deliveries brought some relief, and American radios, including SCR 508 sets, began to be installed on Soviet command tanks. But even by the end of the war, only about 25% of Soviet tanks had radio communications. This comparison highlights even more vividly the colossal scale of the American achievement. While the Soviet Union struggled to equip at least a quarter of its tanks with at least some kind of communication, America achieved 100% equipping of its tank fleet with the most sophisticated advanced FM systems. The Motorola plant in Chicago has become a symbol of American industrial mobilization, working to the limit of its capabilities. Before the war, this company produced conventional car radios, but the transition to military rails required a complete retooling of production and the solution of unprecedented technical problems. Each SCR 508 radio station contained 2,748 individual components, each of which had to be manufactured with the highest precision. The BC64 transmitter contained 474 capacitors and 385 resistors, and each of these elements was supposed to work flawlessly in the hell of tank combat. Quartz oscillators had to maintain frequency stability despite extreme temperature fluctuations from the African heat to the Ardennes frosts, and constant vibration from the movement of a multi-ton machine. Production statistics spoke louder than any propaganda slogan about the power of the American industry. In 1942, 3,800 radio stations of the 508 family were released. In 43, 11,400, and in 44, 24,000 units. The total production volume during the war exceeded 50,000 tank radio sets. This manufacturing miracle ensured that all 49,324 Sherman tanks rolled off the assembly line during the war received state-of-the-art radio equipment, an achievement that no other nation has even come close to. The advantages of the SCR 508 went far beyond frequency modulation alone.
Quartz frequency stabilization meant that the tankers could pre-tune the channels before the battle and be sure that the connection would not be lost at a critical moment due to the frequency departure, while the German radio stations, Fugue 5, with their variable capacitors, constantly required adjustments, distracting the crew. The dual receiver configuration allowed the commander to simultaneously control the network of his platoon and the network of the company commander, so that orders instantly descended through the chain of command and senior commanders maintained full awareness of the situation among their subordinates. The BBC 66 intercom system was seamlessly integrated with the radio station, allowing all crew members, from the driver to the loader, to inform the commander about threats.
Laryngophones that read the vibration of the vocal cords, and noise-canceling headphones provided clear communication in the midst of the infernal noise inside the tank. Many German tanks had no intercoms at all, forcing the crews to communicate by kicking, gesturing, or shouting, wasting precious seconds. Nutrition management was another hidden trump card of the Americans. The SCR 508 station could operate from both 12 and 24 volts, automatically adjusting to the voltage of the onboard network. The dynamo-based power supply provided a stable, filtered voltage that completely eliminated electrical interference, while German radios, powered directly from the onboard network, caught every spark like a static crackle. The tactical advantages of the widespread introduction of radio communications have radically transformed the American armored doctrine. The structure of combat commands, flexible temporary groups created for a specific task, relied entirely on reliable communication. American commanders could form combined detachments from different battalions and regiments on the move, confident that they would be able to coordinate actions through compatible radio stations. This tactical flexibility was confusing to the German generals, who were accustomed to rigid organizational structures that were necessary precisely because of communication constraints. During the famous Battle of Arakura in September 1944, the 4th Armored Division of the United States faced several German tank brigades equipped with the latest Panther tanks. The Germans had an overwhelming advantage in the armor and firepower of their guns, but American radio coordination was the decisive factor in victory. Each Sherman could instantly report the appearance of an enemy. Tank destroyers were receiving target designation from tanks they hadn't even seen. Artillery observers stationed in the commander's Shermans fired devastating volleys literally minutes after the targets were detected. In 3 weeks of fighting, the 4th Armored destroyed 281 German armored vehicles while losing only 41 Shermans, a loss ratio of 7-1, which completely contradicted the comparison of the technical characteristics of tanks on paper. Throughout the war, German intelligence could not fully comprehend the true significance of American superiority in communications. The excellent coordination of the Americans was constantly noted in combat reports, but it was mistakenly attributed solely to the quality of crew training, not technology. An analytical report from German intelligence captured in September 1944 stated, "American tank units demonstrate good radio discipline and coordination. Apparently, this is the result of intense training and rigorous communication procedures." This report completely overlooked the main thing: the technological superiority of the equipment itself. German tactics have not been able to adapt to American capabilities. They continued to target the alleged commander's tanks, focusing on the number of antennas, not realizing that any Sherman could take control of the battle. They planned ambushes, assuming that the American tanks would lose coordination once separated, not realizing that radio contact preserves the integrity of the unit regardless of visual contact. In March 1945, when American troops approached the Rhine, their leadership superiority reached its peak. The seizure of the Remagen Bridge has become a textbook example of the speed of the American decision-making cycle. When the 9th Armored Division found the Ludendorff Bridge intact, the radio report reached the headquarters of the 1st Army in a matter of minutes. Within an hour, divisions along the entire front were already changing directions of attacks to take advantage of this unique opportunity. German troops, dependent on wired telephone lines that were systematically destroyed by American aircraft and saboteurs, simply could not react with comparable speed.
The American radio coordination has created an impenetrable defense around the captured bridgehead. Tank platoons from different battalions seamlessly integrated into a single fire system, coordinated via radio networks. German counterattacks, poorly coordinated due to communication failures, arrived in parts and were destroyed separately. April 1945 and the encirclement of the Ruhr Pocket demonstrated the culmination of American superiority in command and control. The American tank columns of the 1st and 9th Armies coordinated the most complex double coverage exclusively using radio communications. 325,000 German soldiers were trapped inside the cauldron, partly because their communication system had completely collapsed. American fighter bombers, guided by advanced aircraft manufacturers with radio stations, methodically destroyed German communications hubs. The Wehrmacht units lost contact with the Supreme Headquarters and with each other. Field Marshal Walter Model's last radio messages before the complete failure of communication painted a picture of despair. There is no contact with neighboring units. There is no communication with the higher headquarters. The struggle continues, but coordination is impossible. The American radio revolution had a profound impact on the psychology of tank warfare. American crews went into battle with the firm knowledge that they would never be alone. Even when they were physically isolated in a forest or a city, they remained part of a single whole thanks to radio waves. The German tankers experienced the opposite, a feeling of deep, chilling isolation. Unable to communicate, they fought their individual battles within the larger battles. Otto Carius, one of Germany's most prolific tank aces, described the difficulties of limited communication in his memoirs, Tigers in the Mud, although he focused more on tactics than technical lag. The strategic consequences went far beyond individual skirmishes. The rapid advance of the Americans in the 44th and 45th years maintained a high pace, largely due to radio coordination which the Germans could not reproduce. Patton's famous Third Army surge through France relied on radio networks that allowed troops to be controlled over a space of hundreds of miles. German commanders constantly underestimated American capabilities because their thinking could not accommodate the concept of such total radiification. Heinz Guderian, already the Inspector General of the Armored Forces, recognized the problem but was powerless to solve it. In a memorandum dated December 1944, he bitterly stated that American coordination negated the qualitative superiority of German tanks. After the German surrender, U.S. technical intelligence teams carefully examined captured German equipment. Their findings only confirmed what combat experience had shown. German tanks often had better armor and guns, but were catastrophically inferior in communications. The U.S. Army Technical Intelligence Report No. 176 stated that German tank radio equipment lagged behind American equipment by about 5 years. The lack of frequency modulation, the limited distribution of radio stations in the military, and poor protection from electrical interference created critical vulnerabilities. Soviet experts came to similar conclusions. The Red Army, having gained access to captured German equipment, preferred to copy American radio station circuits rather than German ones in post-war developments. Production and deployment statistics show the true scale of the American triumph. The United States has produced more than 50,508 type radios and equipped 100% of its tanks with them. The transmitter power was 25 watts, the frequency stability was provided by quartz, and the communication range in motion reached 7 miles. Germany, on the other hand, produced only about 6,000 Fugue 5 transceivers, with the production of about 12,000 medium and heavy tanks, providing only 20% of the fleet with full-fledged communications. The power of their transmitters was only 10 watts, the frequency was constantly floating, and the range in motion dropped to half a mile. The difference in communication efficiency was devastating. The average execution time for an artillery strike for the Americans was from 3 to 5 minutes, for the Germans from 15 to 30. 100% of the American tanks could coordinate actions against 20% of the Germans. This radio superiority of the Shermans laid down the fundamental principles by which armored warfare is still being built today. Modern main battle tanks carry communication systems on board that trace their lineage directly from the SS-508, digital, not analog, but based on the same principles of universal connectivity and reliable coordination. The German Bundeswehr, revived in the 50s, drew the right conclusions from the lessons of the war. Since its creation, each Leopard tank has been equipped with integrated radio systems.
One of the Bundeswehr's training manuals explicitly states, defeating superior German tanks by inferior American vehicles with better radios teaches us that information dominance is more important than platform superiority. Modern conflicts only confirm this lesson. In the 91st Gulf War, coalition forces with excellent communications defeated Iraqi forces equipped with individually powerful Soviet-designed tanks, but with backward communications. In the year 2003, American troops proved once again that a network-centric war always defeats a platform-centric one. The history of the radio superiority of the American Sherman tanks is a story of victory in the electromagnetic spectrum, which proved to be more decisive than any advantages in steel or gunpowder. German tankers fought, being partially blind and deaf to this revolution, realizing too late that each Sherman was not just a combat vehicle, but an active node of the first combat network in history. The SSR 508 radio station turned the Sherman from just an adequate medium tank into a deadly component of a unified weapons system. This transformation had an effect greater than any armor thickening. Each Sherman carried the tools of victory not only in the form of a 75mm cannon, but also in the form of 181 pounds of electronics, connecting its crew with the full power of the American Army. This connection created a collective intelligence that no individual German tank, no matter how powerful, could withstand. The Wehrmacht was never able to develop effective countermeasures because they never understood the essence of the technological gap. The phrase attributed to Field Marshal Wilhelm Keitel at the signing of the surrender, "We knew how to build the best tanks, but you knew how to make them work together," reflects a fundamental truth, regardless of whether it was actually uttered. America has built not just 49,324 tanks, but as many nodes of the global network. The revolution in military affairs, which is today called the network-centric war, actually began in 1942 with the first battle of the radioed Sherman. Since that moment, the war has changed forever. The side with the best communications inevitably defeats the side with the best weapons. The network beats the platform, and the connected ones defeat the isolated ones. This transformation went unnoticed by the Germans until the very end. They saw tactical superiority, but did not understand its technological foundation. The failure of the German command to recognize and adapt to American communications dominance remains one of the greatest intelligence failures of World War II. In the end, the invisible waves carried by the SSR 508 radio stations turned out to be more powerful than the armor-piercing shells of the legendary German 88 guns. The ability to coordinate, share information instantly, and fight as a single organism rather than as a set of machines, it was this invisible advantage that determined the outcome of the war more surely than any visible factors. The radio superiority of the Shermans established the principle of modern warfare. Communication is life, isolation is death. If you want to learn more about such hidden factors of history, subscribe to the channel and be sure to write in the comments what, in your opinion, is more important for the tank: impenetrable armor or perfect communication, because this dispute is relevant to this day.